lightning round is Oscar from Mystic AI. And Mystic AI is actually a Y Combinator company. I think they're based out of the UK in Bath. And he is going to talk to us about something that I'm personally really curious to hear more about, open source LLMs. Hello, Oscar. How's it going?
Hi, Lily. Thanks for having me. Very good.
Yeah, of course. All right. Here are your slides in all of their glory. I will let you take it away.
Awesome. Thank you, Lily. So we're going to basically talk about some of the considerations when it comes into deploying these open source LLMs. So I'm sure like many of you are probably familiar with this scenario in which, management team goes to the data scientists or ML engineers and is like, oh, these models are amazing. Let's see how we can make it valuable for our product. But, how do you get there? And so really the question that everyone is kind of asking is, how do I go from this LLM big model into getting a fast, secure, scalable API endpoint? So something like similar to like OpenAI does with their own private models. How can I do the same experience, but with open source models or the LLM that maybe I've trained myself? And so at the end of the day, it all actually becomes a very similar software engineering problem to other ML models that we've been deploying. It's just maybe potentially more memory required to actually deploy this model. And so if we go through some of these challenges, we know that each model actually is different. And so because of that variability, one of the things that happens is that each of them require different libraries, different packages to run. So you need to have a system that is able to manage whatever is the environment required to run this model. Now, as we mentioned, LLMs are one of those beefier models. So like they require actually a lot more GPU memory than other models that maybe we are familiar to have in production. And so having a consideration for GPUs that are able to run those models is also very important. Having a system that is able to take care of large, when there's a lot of memory required to run this model. And so with that in mind, you actually have to think about which is the best GPU that is going to like deploy this model. But where we are heading towards the kind of like solution is one that you don't even have to think about all of these things. But one actually has to think every time they deploy a model is exactly the requirements from a library's perspective and memory as well. And so one of the classical pitfalls and drawbacks that we're seeing right now is the limited amount of GPU availability to actually run all of these models, because they consume so much memory and those are actually very expensive and everyone wants them. And so it's how do you access a huge pool of GPUs when maybe one cloud provider doesn't have access? So like, how can you easily go to a different cloud provider that maybe actually has the GPUs that your model requires? Then when you're actually thinking about like scaling this model, is one thing is deploying it on one instance on one GPU, but then you actually need to consider, how many users are going to be using this model? Is it going to be just one user? How many requests is going to be handling per second? And then you actually have to consider potentially hundreds of requests per second. And so if it's running concurrently, that means actually hundreds of GPUs running at the same time. And so you need like a software that is able to actually take care and dynamically scale according to how many requests that given model is asking for. And then at the same time, we obviously want to make sure that we don't spend thousands and thousands per hour on running some of these models. And so you need some kind of software that is able to dynamically optimize for how many what is the most optimal GPU to actually run this, and there's different techniques like using spot instances, leveraging multiple cloud providers in which one of them may be cheaper than the other, etc. Now, obviously, you want to make sure that the end user experience is as optimal as possible, and so we are targeting, or like ideally, the industry should be targeting sub 50 milliseconds of API latency, which would allow a much more easier experience for something like streaming. Then other optimizations that one has to think is, how do you make sure that everything is ready on the GPU when the user is about to do an API call to this model that has been deployed? And so something that we call preemptive caching is, how do you make sure that the model is cached ahead of time of the request being processed? As well, as I mentioned, if you actually want to like be able to run maybe the nicest experiences that we are seeing with LLMs is that kind of like streaming as if you were like talking to someone or chatting to someone. Is like the word comes out as soon as possible, and as opposed to having a chunk of text being thrown into you. And so like you need to have a software that is able to actually provide that kind of streaming, as well as being able to deploy this type of models in the easiest way possible for the data scientist team, and they don't have to go through massive amount of layers of maybe software development or actually teams to ask them, hey, I have my Jupyter notebooks or my models, please deploy them, make sure it all works. How can we bring that barrier closer into the data scientists and empowering the data scientists to do it themselves? Then obviously you need to make sure that you're monitoring the full system, so because things break, so being able to quickly resolve whatever is that breaks. And of course, you, especially with open source, that's one of the reasons why it's so exciting for many, many companies at any scale, is to actually be able to run these things on your own premises or on your own cloud, VPC, whatever. So you want to make sure that you optimize privacy and security. And so you need software that is able to be deployed whichever are the premises that the company that you're working for requires. And so how all of these challenges, how are people like currently solving them? I think there's like three kind of like higher overview type of approaches. The option one is, let's look at like what is the current software engineering team and what are the skill sets that they know how to use, how to leverage. Classic Kubernetes plus Docker, and let's just make sure that each Docker file, well, each Docker has a different model, and we just leverage K8s for the scaling. And that's what we are used to because we run a lot of microservices, mostly on CPU compute, and we assume that potentially this is going to be the same for GPU workloads. Surprise, it's actually not the same. But you know, there's a lot of like challenges that come when you actually try to deploy things on Kubernetes for specifically GPU compute. And so it's a good thing to actually approach it this way because it gives you a full control and you're able to actually deploy it in the infrastructure that you maybe already have in place, but also requires the experience or an expertise of knowing how to build this with all the challenges that I've just mentioned and how to make sure all of this get solved through the infrastructure, through the software that you are that you already have in place in your company. And obviously, building something like this from scale from the beginning, this internal ML platform actually does take a lot of time. The second option is you look at a cloud and then you just use whatever is the solution that they have, like Vertex AI, AWS SageMaker, etc. Problems with that is obviously you are you're going to be like limited to whatever is the cloud provider that you're going to be choosing from the beginning. And so there's a lot of like cloud lock-in, of course, and then you require still the expertise on that specific cloud vendor, and it obviously will take still time and the time and the resources to actually maintain all of this infrastructure in this cloud vendor that you've chosen. And then finally, the third option, which actually is now rising a lot more, is new different competitors and players trying to give you a solution which gives you all of this infrastructure out of the box, right? So like going into the first question I was saying, like, how do you get, given this model, how do you get this API endpoint out of the box? That is the goal, right? And so this is actually one of the solutions that I'm going to be talking about, which is the product that at Mystic we have built, which really allows companies right now to actually get fast. It's the fastest to go to market because everything is there. All the challenges that I've mentioned are solved. Allows teams to actually deploy these LLMs immediately, whatever they wanted in any cloud provider, et cetera, et cetera. The only challenge, the only problem with that is that obviously you're not building the infrastructure yourself, so maybe you are not getting those learnings. But companies have so many other challenges that maybe they should be focusing as opposed to be focusing on the infrastructure of deployment. Same that we don't focus on infrastructure for payments. Stripe handles that. Maybe we should allow other companies to handle the infrastructure for deployment. And so this is where Pipeline Core comes in, which is the product that we built at Mystic. And really, it's very much built for the data scientists, with the data scientists in mind. It's how can we empower the data scientists to deploy these models in a reliable infrastructure immediately. And so it all starts with a simple amount of decorators. Like for instance, in this one I'm showing here is just you decorate different functions that you need to define your machine learning pipeline. The beauty of this is that it's not limited to any framework. You can actually do whatever you want. You can, run combinations of different frameworks. You can have some pre-processing code, post-processing code, whatever Python code you want to run. This supports it, right? It's not limited to a specific PyTorch file or TensorFlow file, for instance, that we see some other softwares. And so this is for loading the model. In this case, it's very simple. I'm just loading. Actually, this one is for the Falcon 8 7B. Then you basically eventually, so there's another function that you define actually how the inference path should be built. You then define the step-by-step of the machine learning pipeline. And then finally, I wanted to show you a bit of a demo, but I'm running a bit of time. But basically, it's just a load test allowing you to suddenly, as soon as you've defined this pipeline, you upload it and you get an API endpoint to actually hit scale with this LLM that you just like uploaded into your platform. And out of the box, you get a dashboard to actually monitor how well your platform is doing. And so this is one of our customers where they are getting like a P95 or 25 milliseconds. So what you can think about Pipeline Core as this, with a simple SDK, we really give the companies the power of an experienced DevOps team for ML workloads. With like dynamic scaling, cost optimization, you're able to deploy across any cloud, on-prem, instantly run streaming, batch, online inference, and a bunch of other amazing things. And yeah, so we are definitely like onboarding companies right now. We are handpicking them, so please go for it. Try book a demo. I'll be in touch. One of our team members will be in touch with you, and we'll love to be able to show you more about what is it we build with Pipeline Core and help you get deployed those models that you have as soon as possible into whatever infrastructure you desire. And yeah, thank you so much for your time. If you need anything from my end, you can reach me out on LinkedIn. You can reach me out on email, or feel free to reach out on us at mystic.ai, or please do book a demo and I can show you a lot more about Pipeline Core. Thank you so much.
Awesome. Thanks so much, Oscar, and so excited to hear all the new stuff that's going on in Mystic AI. Thanks for giving us kind of a preview of what's going on.
Thanks, Lily.
Cool. All right. So we'll send you to the chat if people have questions for Oscar.